start, I want to tell you, Noam mentioned before, a way to get famous is by breaking production. Well, let me tell you something. When I was at Wix for about 3 months, by the way, I've been at Wix for about almost 4 years, but when I've been at Wix for about 3 months, I broke production. And I broke production for about 15, close to 20 minutes, which is, Noam said before, more than 5 minutes and you really get famous. Luckily for me and for the company, it was on Sunday morning at around 10 a.m., which is more or less the most quiet time for us in terms of traffic. The second thing is that I only broke production for about a third of the sessions, not for 100% of the sessions, lucky me. And the third thing was that I myself caught it, so by the time that complaints were starting to pour in, we were already in the process of rolling out a fix. But yeah, it made me gave me a slight notoriety for a while. And as you can see, I wasn't fired, so there's that. Okay, so today I'm going to talk about improving load time for 100 million websites, which is more or less what we have at Wix. If Noam's talk was like a sort of a deep dive into one particular technology that we used for improving performance, my talk is going to be more of an overview, as it were the tip of the fork. It's more of a starting point for you to, if you're looking for ways to improve performance on your own websites, at your own company, I'm going to list a whole bunch of topics and suggestions and technologies, and then you can, do more research into any one of them. A lot of them are subjects for complete talks in and of themselves. Obviously, you will have access to these slides and the video so that you will be able to pursue these topics for more information. But so before I even introduce myself, I will in a minute, why should you even be listening to me? And to answer that, I'm going to tell you a short story. So this is kind of a similar graph to what Noam showed before. Here I actually left the date on, but unfortunately for the same reason as Noam, I removed the numbers. But I can tell you that this is 0. So what you're looking here is, so when you see a rise like that, it's a rise of approximately what, like 15, 20-something percent. By the way, the numbers here are the 10th percentile, 25th percentile, median, 75th percentile, and 90th percentile. You should usually care more about the 90th percentile because if you're large enough, that's where the action is at. In any way, what you can see here, the lower percentiles seem kind of flat, mostly because you can hardly see them at this resolution. But you can see that between something like January of 2017 and around August of 2017, we were busy. And we were busy, and we added a whole bunch of features into the product. We made the product significantly more powerful. We made it more stunning. Users could use a lot of additional features in the product. And as a result, the product was a lot better. But it also was a lot worse. And it was worse because, as you can see, the load time for websites built with Wix increased by around 20-something percent during that period of time. And let me tell you, users weren't happy. And it's not as if our load time was so great before that. Even before that, we wanted to improve our performance. So having a situation where our performance actually degraded by approximately, 20-something percent was really bad. So again, why should you be listening to me? You should be listening to me because of that. Because after we came to the realization that something had to be done, we started doing it. And I'll talk about exactly what we did and how we did it. But this is a graph for computers in the US. As you can see, this is Wix site desktop performance. So this is performance on desktop clients. And from August to around March, we were able to reduce the load time by somewhere between 20 and 30%. And we did that even though we continued to add significant features at a very rapid pace. If you've heard about our Wix code functionality, it's a really substantial enhancement to the Wix platform, really transforms us from a site builder into a platform. This was added over this period of time, and it added a lot of functionality into the product. So being able to improve performance by such a significant amount while this was going on wasn't trivial. Noam stole the thunder for this slide. This actually shows what happened on mobile, thanks primarily to, as Noam mentioned, to SSR. As you can see, in this case, we didn't improve performance by 25%. We actually improved performance in many cases by as much as 75%. I've saw sites with heavy traffic and looking at actual user data from the field. These graphs are not, our tests. It's not me loading the site on my computer and comparing the two. It's also not synthesized tests on VMs all over the place. These graphs are based on actual user data. We actually monitor the performance of all Wix sessions. So this is data from the field, from the US in this case. And as you can see, overall, we improve performance by around 70%. That's dramatic. That's going down, just a second, from an 8-second load time on mobile, or let's put it 8 seconds until first contentful paint, to around 2 seconds until first contentful paint. Yes, please.
Can you say what you measure here and how you measure it? Like what's the benchmark?
Okay, so we actually have a mechanism. There are a lot of solutions out there in the market that enable you to instrument your product and send notifications or events, either to report errors, to analyze the funnel, and to also measure performance. In our case, because of the amounts of data that we handle, it was actually beneficial for us on the client side to use our own solution. I actually had an entire session on that, so I can't really go into details here. But basically, we send notification into a system that stores some of it in perpetuity. Some of it just goes into a funnel, gets displayed. We use tools like Grafana, like Anodot, like Hadoop. We have a whole bunch of data analysts and data scientists working at Wix. So in this case, we just send, we programmatically, it's not based on onload or something like that. We programmatically put into code in certain points, we send a notification that basically reports time since navigation start, and we basically measure that. So we have an event that we send when the site becomes visible, and that's what we are graphing here. So in this case, like I said, what gets measured in this case is first contentful paint. For desktops, contentful paint and interactivity more or less go hand in hand. As Noam explained before, in SSR, they're kind of disjointed. So you first get first contentful paint and partial functionality or interactivity, sorry, and then you get full interactivity a little bit down the line. In this case, up to here, before we were using SSR, it were both of them together. Once we started using SSR, what you see on the graph here is first contentful paint. Yes, please. Oh, okay, thank you. So to continue. Okay, so finally, I'll introduce myself. My name is Dan. Like I said, I've been with Wix for almost 4 years. My role is performance tech lead in the editor viewer team, which is like the core team at Wix. And I have my job description is to make 100 million websites load and execute faster. So on a good day, I can come home and say to my wife, hey, look, I made 100 million website load faster. And she's go like, oh, because she doesn't really care, because she's not really into this stuff. But hopefully you're impressed more than she is. You have my contact information up there. Feel free to follow me on Twitter. I tweet. That's the Wix Engineering blog. And this is my email. If you have questions, comments, whatever, feel free to reach out. Okay, so what are we going to be talking about today? First of all, I'm going to talk about how we faced performance, and what I mean by that is how, when we thought about performance and what performance means and how we should look at performance, what were our considerations. Then I'm going to talk specifically about performance at Wix and why Wix, on the one hand, represents sort of an edge condition or an extreme situation, but why, on the other hand, the things that we did are actually relevant to any web project. I'm going to talk a little bit about how we actually measured performance, a little bit of which I already touched on here. And finally, I'm going to provide like a grocery list or a shopping list of like points and action items that we did in order to improve performance, SSR being one of them, but there are also a lot of others. So if you stick around to the end, I think that's the most beneficial part. So facing and understanding performance. The first thing you need to understand about performance is that performance is a feature. And what do I mean by that? I mean that customers expect high performance from their website. You know, there's all these numbers that if your site loads, let's say, slower than 3 seconds, then you're losing like 30% of your visitors. You know, all this stuff is real. And it means that if your site is slow, it doesn't matter how great you make your site, because users are just not, a lot of users are just not going to get to experience your site. The other aspect is that if your site loads really slowly, then users become annoyed, and then anything else in your site is going to, you know, impact them a lot less, because they're already coming into it not with the frame of mind, let's say, that you would like them to have. In our case in particular, you know, users build sites on our platform, and they really don't like it when the sites that they're built are slow, and they complain about it for a long time. Complaints, we measure user complaints, you know, what users complain about. For a really long time, site performance was the #1 complaint. Now it's the #3 complaint. So we've made progress, but we still have work to do. Also, as you may have heard, Google rankings are going to start being impacted by performance. So far, what they're saying is that at least at the first stage or first phase, it's only going to really impact the really slow sites. So if your site is really slow to load, then they will actually lower your Google score. You could argue that if your site is really slow to load, it's probably impacting your Google score anyway, because users aren't waiting for it to load. But Google are going to use that themselves. It's very conceivable that going forward, it's going to be an aspect of SEO in general. So that's yet another incentive. There's another reason that performance should be looked at as a feature. And that is that performance needs to be specified. If the product manager doesn't specify performance requirements when he or she specifies a product, then it's not going to happen. I remember, like, when I joined Wix, more or less, I was talking to a product manager about a certain product, and I asked him why the specifications didn't include anything about performance. And he said, and I remember this, he said, first, I don't know what to spec. I don't know what performance I should ask for. And second, well, you know, I expect the developers to write good code, so they will probably make it as fast as it can be. And I was like going like, but you know, so if you can't assume that, because if performance isn't part of the spec, it won't happen. The developers, they are really busy as it is. They keep on being pressed for adding more features. They'll just bang out the code. QA will not test for performance if performance is not part of the specification. They won't test that the site loads in under 2 seconds, for example, if it's not written anywhere that the site has to download in under 2 seconds. And this other point about it being as like a feature is that you have to allocate resources for performance. If you don't give the developers the time and the tools to and the incentive to write high-performance code, they won't do it. It won't automatically happen. It has to be allocated resources like any other aspect of the product. On the other hand, performance is not a feature. And what do I mean by that? I mean that it's unlike most features, it's never really complete. In this way, in this regard, it's more like let's say a project or a product or a company than it is like a feature. You keep on working on it forever. And one of the reasons is that if performance is not progressing, it's regressing. Whenever we didn't do anything immediate about performance, for example, let's say we were working on a longer term thing and you know, in the interim, other developers continued working on the product, what we saw was that performance regressed. Because you will see in a second, I will give a little bit of info about Wix, but we have a lot of programmers that for some inexplicable reason insist on writing more code. And more code means that it's going to be heavier, it's going to do more stuff, and so it's going to take more time, so performance will degrade. So in other words, performance is like a successful software project. It's a journey. It's not a destination. Like a software project, you're never done. You always have the next step, and performance is like that. One really important thing, again, going back to that product manager that I talked about before, the one that kind of shocked me, who said that he didn't know what to ask for. Well, thankfully, there are now industry standards for what we should be looking for or striving for in terms of performance. Now, you might see that they are really ambitious, and we're not there yet, and it's highly likely that you're not there yet, but this is where we want to be. So again, it's really thanks to Google, who invented this concept called RAIL, which is an acronym for responsive, which means that when somebody does any sort of interaction with the site, let's say clicks a button or a link or whatever, then the feedback should be in under 100 milliseconds. It means animation. With animation, you want to reach 60 frames per second. And 60 frames per second means that you only have like 14 milliseconds tops for actually running the JavaScript that would create the next frame. Why is that? 17 milliseconds per frame. And what can we do? The browser has its own overhead. The browser also needs to do some stuff. It's even slightly less than 17. If you can't hit 60, then 30 might be the next good stop to be at. And then you have, let's say, approximately 23 milliseconds to do your stuff. And of course, you want to use request animation frame. The next one is idle. Idle means that if you have lengthy tasks, you can either move them to a worker, but let's not talk about that for now. Instead, you would break them down into 50 millisecond segments and use something like request idle callback to schedule them. Why 50 milliseconds? Because if it will take more, then there's a good chance that you won't be able to achieve responsiveness in 100 milliseconds because the browser would be busy if the user for some reason decided to click something in the middle of such an idle operation. By the way, if I didn't mention before, well, you already did this, but I'll say it again. Feel free to raise your hand or to ask a question, make a comment, whatever. And finally, load, which in usually now a lot of people talk about first contentful paint because it really goes to the concept of perceived performance, of the user actually seeing something. Ideally, we're talking about first contentful paint in 1 second or less. Allowances are made for mobile when they're saying that 1.2 milliseconds is also nice. Yes, please.
How does a product manager communicate performance requirements on a feature-by-feature basis? Because this seems to me like a standard that you would put on a wall and say, okay, let's strive for that. But when you're developing a single feature, what would they communicate?
Well, for example, so the question was about how a product manager might be able to communicate performance requirements. So first and foremost, so let's make a distinction between how to determine what performance requirements to make, and the second one would be how to communicate them. I'll start with the second one because it's easier, and you would communicate performance requirements in exactly the same way that you would communicate any other type of a requirement, which, for example, you could say in the specification document if you have one, or in the Jira ticket or whatever way you use to communicate requirements, that when the user, let's say, clicks a button to open a dialog, that dialog should open or something in the display should be updated in, let's say, under 100 milliseconds. Now, these are guidelines that you need to kind of match to what the current situation is at the company or on the project that you're currently working on. You can't just go in and say, well, our load time up till now has been such and such, let's say 5 seconds. I'm adding a feature, and also the load time has to go down to 1 second. That won't happen. But you can say that I'm adding all this functionality, and I expect that load time won't decrease by more than 5%. So that might be a statement that you'll be able to make in this context. You have to be reasonable, and you should be able to find material about this online. Okay, so let's talk a little bit about Wix in particular. So what are our challenges? So we have tens of millions of sites and millions of domains. Most companies that work in web have 1, 2 websites, and we have, on the other hand, we have tens of millions of websites, and we have millions of different domains. So that means that, caching strategies are really different in our scenario than there might be in a scenario where everything is going to the same domain. We have a wide variety of site types and capabilities. There are sites with e-commerce and without e-commerce. There are sites with blogs and without blogs, with videos and without videos, and so on and so forth. So many different possibilities, so many different permutations. We have 7 years of legacy sites. People who built their site 7 years ago, their site needs to continue to work and look exactly the same way as they did, even if they haven't touched them at all in 7 years. So we can't just say, okay, we'll improve performance by making some sort of a breaking change. It just doesn't work. And there is a wide variance in visit rates for the different sites. There are sites that get tens of thousands of visitors every day, and there are sites that get a few visitors every month. And again, we want to provide good performance for all of them. And last but not least, since we're a do-it-yourself platform, these are user-designed sites. So we do guide the users. We give them templates that they often start from. But at the end of the day, first of all, our #1 most popular template is the blank template. People just often like you starting from scratch. And even if they don't, the Wix approach is very, very flexible. They can literally change anything in any template, which means that, if somebody decides to put, 20 fonts, custom fonts in their site, they can do that. And I don't really have a direct communication channel with that person to tell them, hey, you know, what you're doing, that's not a good idea performance-wise, and probably also visually, because 20 fonts, let's face it, is way too much. So what did we do? When we reached that point, for example, in August, and even before that, when we saw that performance was degrading so much and user complaints about performance were increasing, what did we do? So first and foremost, performance was declared to be a top priority company-wide. The CEO of the company addressed the entire company, listing 3 top tasks for the entire company. I won't go into the other 2, but the first one that he mentioned was performance. So performance was really declared to be a company-wide top priority with the appropriate resource allocations and care. And in this context, there is direct engagement from top management. I talk to a member of top management, I mean a VP senior, a VP level person or higher, essentially every day about performance in some way or another at Wix. So a CEO of the 2,000-person company is deeply interested in performance. When we had a recent company update, our COO, one of the first slides that he shows was that performance graph that you saw before. We have significant resource allocations. You know, we talked about the SSR project. That's a significant allocation in terms of resources. I think something like 10 man-years went just into building that SSR system that we were talking about. And there are, you know, we are paying tens of thousands of dollars for servers for doing that server-side rendering. So we are willing to put our money where our mouths are. So it also means that we did, for example, performance reviews for all the projects at Wix, and you know, basically told them these are the things that you need to fix in each and every project, and those were classified as top priority. We also had dedicated performance teams, as I mentioned, like the SSR team, like additional teams, working specifically on performance-related features and functionality. And we put people that had performance-related tendencies in positions across the company. And we now consider performance regressions to be blocker bugs. So when there is a regression in performance, and we know where the regression is, you know, you need to identify it, we won't release a version that we know that has a performance regression. And if we have a performance regression in production, we consider it to be a bug, and we work to fix it before we keep on throwing new features out there. So we talk a little bit about measuring performance. There are like 3 main phases at which we look at performance. One is during development. Chrome DevTools is an excellent tool for, you know, for really deep dive technical analysis of performance. But there are other tools that can be used during the development cycle by, let's say, product, like, you know, it might be webpagetest.org, or it might be Google Lighthouse. And there are many other such tools these days that can be used to measure performance at production, at development time, sorry, not production. In our case, for example, because the dev tools are so sophisticated and change so often, we actually had internal company training, which we do every couple of months, to the developers about how to best use the Chrome DevTools for analyzing and measuring performance. We also invested time and effort in a tool that I hope that we will be able to open source in a couple of months, I hope, which is intended to automate pre-release performance testing. That means we want to be able to essentially catch and identify performance regressions as a part of our continuous CI and CD process, and avoid accidentally pushing out regressions into production. So in order to do that, we wanted to be able to catch really even small performance regressions, because, you know, if you have a 5% performance regression, or 3%, let's say, performance regression every week, then within a month, it's already 12%, and within 2 months, it's 25%. So you want to catch that early, because otherwise what will happen, let's say you say, oh, this is my baseline, and I'll raise the red flag when we have a 20% performance regression. Well, what you will see will happen is that it will gradually increase, and then you'll sort of have the straw that breaks the camel's back, but that poor soul that caused it, well, he just caused a 2% regression in performance, but that added on top of another 18% that just accumulated over time. So we wanted to avoid that. And in order to have such a fine-grained measurement, we needed to eliminate deviations, which means, first, for example, we run it on dedicated hardware. That means we have a box that we know it runs just this test, so it gives consistent results. It's not a virtual machine. It's just a physical box that runs these tests in a loop. The other thing is we eliminated the physical network. That means we actually, when we measure for a site, we actually scrape the site, put all the resources locally, and then run it through a virtualized or simulated network. So this way we get a consistent network response time. So we eliminate the vagaries of an actual physical network. And we didn't try to be too smart about trying to figure out when exactly the site is updated. Instead, we basically told the developers, put markers in the code itself using performance.mark and performance.measure. If you're familiar with these APIs, if you're not, check them out. They could put markers in the code, and we would actually measure these markers. So they could put the marker, when the site, let's say, starts the React render and when the site finishes the React render. And that way we could, for example, measure the amount of time that rendering takes. The graph looks something like this, where we have the various sections. Each represents a different segment that we're measuring. They're cumulative. And as you can see, in some places, like here, we had performance improvement when we opened a certain experiment, and then we closed that experiment, so it regressed back to where it was before. We were testing an experiment that we hope will improve performance. And you can see the results are not 100% consistent, but fairly consistent. The deviations are really in like the single percentiles, which enable us to catch regressions. And like I mentioned before, we also measure performance in production, because with all due respect to simulated systems, they don't reflect reality. Like I said, so many countries, so many types of users, so many networks, so many devices. The only recourse for that is to actually measure performance in production, and we measure a ton of stuff. We measure, like I said, we put markers in the code that measure time-sensitive navigation, but we also measure stuff like DNS lookup. We report the DNS lookup time. We report the time to first byte and the kilobyte per kbps for downloading files from the CDNs. Yes, we've actually encountered scenarios where CDNs did not live to their promised SLAs in terms of performance. And when we told them, they actually fixed it. Otherwise, we wouldn't have known. So, we are big enough to invest a lot of effort in actually doing this ourselves. There are a lot of third-party tools out there that you can use as well. And if you have a site that's facing customers, you need to be able to measure performance in your site in some way or another. Okay, so now finally we get to the good part, in which I'm going to talk about, as I said again, just touching on the various things that we've done to improve performance. Now, a couple of things. First of all, we've done things to improve performance also for responsiveness and frame rate. I'm not going to talk about that. The focus in this talk is going to be only about the load time, so that's point number one. Point number two, you might notice that if you start adding up the numbers, 10% here, 20% there, you'll say, hey, wait a minute, that's 150%. You're loading in negative time. Well, unfortunately, that's not the case. If you know that every time you improve performance by 10%, you'll never actually get to 0. And like I said before, we also have, unfortunately, we also have performance regressions. So the numbers do reflect the improvements that each and every one of these features did, but cumulatively, it's not always ideal. Let's put it this way. Okay, so one of the best tools for improving performance is still, for JavaScript, is still bundling JavaScript and associated resources into a fewer deployed packages. Modern browsers are adding support for JavaScript modules. That's really, really cool. It's not there yet in terms of performance. If you want to achieve good performance, you need to use some sort of bundling solution, Webpack, Rollup, even Browserify if you're still using that, even concatenation if that's your thing. But you need to be bundling. Why? Well, smaller downloads mean better compression. If you're looking at gzip or some of the newer compression protocols whose names I can never pronounce, then they work better when the files are bigger. A single 30K well, let's say a single 100 kilobyte JavaScript file will compress much better than, let's say, 10 kilobyte files or 20, or certainly 25 kilobyte files. So, better ratio. Yeah, I mean the better compression ratio. It's also another reason for the smaller download is that there's less overhead in the protocol itself, because every additional resource that you need to download is another request and an HTTP header being sent and a response. So there's actual overhead in the protocol itself. Also, it means that by doing bundling, you can avoid blocking when you're managing the resource order. What do I mean by that? Let's say I have two JavaScript files that I would download separately, an a.js and a b.js. If A is dependent on B, then if A downloads first and then you download B, A can't really do anything until B finishes. If you bundle them together, you get them both together. You don't suddenly realize that, hey, I have A, but I haven't even started to download B, and now we have to wait for B to arrive. So there are a lot of benefits around bundling. But as it turns out, there are also a lot of benefits around unbundling. Yes, please.
Did you have any experience with HTTP 2?
Yeah, I'll get to that. So the question was about HTTP 2 in a second. So it turns out that while bundling is very, very beneficial, it turns out that unbundling is also very beneficial. Breaking up large bundles into smaller pieces can actually improve performance. And why is that? Well, better use of CDNs. For example, I can bundle Lodash into my, if let's say I'm using Lodash or jQuery or whatever in my project, I can bundle it into my distributable. But I can also just take it from a CDN. And the CDN will probably, first of all, the CDN will probably provide better performance than my server. But beyond that, if some other sites that the user visits also get these same libraries from that same CDN, there's a good chance that, especially if I'm using the latest version, there's a good chance that these files will already be cached in the local browser cache, which means that 0 download time for those particular files. So if I'm just using a small piece out of Lodash, I might decide to bundle it in. But if I more or less end up needing all of Lodash, then it might be beneficial not to bundle Lodash and just take Lodash from a popular CDN. Fewer cache busts. The more I bundle, if I bundle the entire project into a single file, then any change in the code will result in a cache bust. On the other hand, if I break it into 5 pieces, then every change will probably only cause a bust in 1 or 2 files, and the others can still be cached or read from the cache. We avoid downloading unneeded code. When I bundle stuff, let's put it this way. I've seen a lot of cases of over-bundling. When we did the performance reviews for the various projects, we literally saw a project that had bundled Immutable.js 5 times into the same bundle. NPM makes this sort of shit extremely easy to accidentally do if you don't have your versioning properly configured. So by not bundling, you can avoid downloading unneeded code. You get greater parallelization, which means that I can, with a big bundle, unlike HTML with JavaScript, you can't start parsing and executing the JavaScript until you downloaded everything. So with a big bundle, I need to download the entire bundle, then the browser parses the entire bundle, and then only then does the bundle start to run. If I break it down, I can actually parallelize download, parsing, and execution. So wait a minute. So I said that bundling is beneficial and unbundling is beneficial. So what do we do? And luckily, we can combine the benefits of bundling and unbundling using code splitting. So for those of you, popular packaging tools like Webpack provide capabilities for doing something like code splitting, which basically you can tell it, create a bundle, but this part delay loads, so it actually simulates a single bundle, but in effect, it creates multiple smaller bundles and downloads stuff on demand very smartly. So this is something that you can definitely leverage. So HTTP2, for those of you who don't know, is the relatively new edition of the HTTP protocol. After having HTTP 1.1 for something like 20 years, they finally came up with a new version a while back. It provides a lot of benefits. And in general, you want to be using it. So if you're not using HTTP2, use HTTP2. And there's essentially no reason not to. All the CDNs support it. All the modern servers support it. Everybody supports it. You get stuff like compression for HTTP headers, which can be important because headers can be up to 8K. And especially if you've got a lot of downloads going on, this can add up. And you get HTTP server push, which means that the client asks for one thing and the server says, hey, but if he asks for that, he's also going to need that. And then he can send 2 responses for a single request just because he knows the client will need that eventually. You've got stuff like pipelining and multiplexing. Noam in the previous talk was talking about how many resources a browser can download in parallel. Actually, the question should be asked about how many resources could be downloaded in parallel from a single domain. With HTTP 1.1, per socket, it's essentially 1, which is why the browser usually opens something like 6 sockets per domain, which means that you get 6 parallel downloads. With HTTP 2, you get stuff like pipelining and multiplexing, which effectively means an unlimited number of downloads over a single connection. So you can download a lot of stuff simultaneously. Basically, we know the improvement that HTTP 2 gives us for a very funny reason. Well, funny is because we had a problem in our production systems which disabled HTTP 2 for a couple of hours. And we saw a performance regression of somewhere between 10 and 20% until we fix it. So now we know how much it's worth for us. But really, the benefit depends on the number of resources that you're downloading. Like I said, with HTTP 1.1, you usually wanted to restrict yourself to around 6 resources to download from domain. With HTTP 2, you can go as high as 50, although that's a bit excessive. I would say somewhere between 30 and 40. That's a pretty good number. And that can give you a good results. On the other hand, don't just break it into small parts, because like I said before, then you lose out on the compression. Caching. There's almost nothing that can beat the resource, the performance benefit of already having the resource cached in the browser cache. I mean, if the resource is already in the memory cache, that's as fast as you can get. But caching doesn't just stop at the browser. There's also caching at the CDNs. So how can we improve caching? The number of times that I've seen situations in which a resource is downloaded and nobody specified the cache settings in the header, it just kills me. That's like the easiest thing you can do, and it so often gets overlooked. And if you don't specify cache settings, then the resources isn't cached. So specify reasonable cache headers. You want to cache resources for as long as possible. Well, one problem, of course, is if you cache for too long, then if you actually change the resource, the browser won't go and get the newer version. And the way to work around that is to, let's say, put a version or a hash directly in the URL. So, for example, in our case, we actually, the initial HTML response has the specifications of the URLs where to get the various JavaScript bundles from. That contains either a version or a hash, which means that each bundle can effectively be cached forever, because when we change something, we basically update the version in the URL itself. Again, use libraries from common public CDNs. I mentioned that before. And if you is everybody familiar with the term e-tag? E-tag, basically, the idea with e-tags is it's a hash of the resource that's sent down in the HTTP response header. Now, when the cache time runs out and the browser is forced to make another request for the resource, it actually sends that hash as part of the request. And the server, if it sees that the resource actually hasn't updated because that hash still matches the hash of the server on the server side, the server can actually send a response that says, just a header which says, you're good, keep on using that resource. So you still have the request response, you haven't avoided that, but at least you've avoided the resource download. So that's e-tag. Selective download is a mechanism that we implemented at Wix, which is kind of doing download on demand and taking it to the next level. In our case, users built sites. So if one user builds a site with a video player, the other you built a site without a video player. So ideally, we would like to avoid downloading the video player to the site that doesn't actually use it. So selective download is about avoiding downloading unneeded JavaScript resources. If you know that a certain JavaScript resource is not needed in a particular scenario, just don't download it.
But wouldn't the splitting, code splitting, will take care of it?
Yeah, so in a sense, code splitting or tree shaking, actually, in this case, is what you're looking at. I'll get to that in a minute. So it's again, so for us, it's a more extreme scenario because we actually download the user specific site definition that they built, and based on that, we know what to download. In most cases where the website is known and fixed, you can use a technique called tree shaking, which basically does an analysis on your JavaScript code, identifies unused code, and just removes it from the bundle. And tools like Webpack or Rollup actually have this functionality built in. It also means that you need to have a synchronous downloading of additional code when it turns out that you actually need it, and that's where code splitting comes in as well. One problem with this mechanism that we faced when we introduced it was that things that previously had been done in parallel, because if you basically download all the JavaScript, then you can basically just download all the JavaScript up front. When you start doing selective download, you need to download some JavaScript and the user data, run the JavaScript on the user data, see which additional JavaScript you then need to download, and then download that additional JavaScript. So stuff that was parallel before now becomes sequential. Resource hints is another very interesting technology that's worth an entire session just about that. Basically, it means that you can put link tags, special link tags in the HTML, or a link setting in the HTTP response header that basically tells the browser you also need these resources. So even before they're explicitly requested, it would be beneficial if you go out and get them so that when they are actually requested, they are already in the cache. Again, going to the benefit of having cache, there's a prefetch setting which basically says, I will probably need this resource, not for this page maybe, but for the next page. So when you have some free time and free network, then it would be great if you could kind of download it as a low priority thing in the background. That's prefetch. Preload means I will definitely need this resource, and I will need it for this page, just I'm not requesting it yet, but I will need it. And so it will, start downloading this, please, so that when I do need it, it's already in the cache. A great example of the use of preload is for CSS, because as you might know, CSS links are render blocking. When the browser encounters a CSS link, it actually needs to stop rendering the HTML, retrieve the CSS, parse the CSS, apply the CSS, and only then can it resume rendering the HTML. So a great solution for that, if you don't really need that CSS up front, is to have a preload link for the CSS, and then when the CSS is loaded, only then actually apply that CSS.
This is similar to request idle. It happens in the idle cycle?
The question about when it doesn't happen, prefetch does in fact happen during kind of idle, although talking about idle in the context of network is not exact. Prefetch is really low priority. Preload gets the same priority as the resource would have had you actually requested the resource. It's just not blocking. Yes, please.
Is this useful in addition to what you can do with HTTP2?
Yes. Push basically means the server knows and decides to send you two things or more simultaneously. This is basically telling the client do additional requests ahead of time. Because of push, all the data comes from the same server. With this way, I can actually do a preload from a CDN. It doesn't have to come from the same server. We got approximately 10% performance improvement by just doing better prefetching and preloading of resources. Progressive rendering. Oh, this is a cool technique that you can use if your rendering library allows you to do such things. Is basically render all the stuff that's initially visible, and instead of everything else, just don't render it or render a blank space. You probably want to render a blank space so that the scroll bar actually exists. And then you fill in the blank progressively after you made the initial part immediately visible, or you make it immediately visible as soon as the user starts scrolling. The advantage is that so what's the advantage? Rendering less takes less time. Just a second. And it also means that you effectively prioritize resource downloads because you render the images that are above the fold before you render the images that are below the fold. So those images will start downloading first, and those images will start downloading afterwards. We saw approximately 5 to 10% performance improvement by you applying this technique, but it's worthwhile noting that in some particularly long sites, heavy sites, we saw up to 50% performance improvement of time to first contentful paint. Yes, please, you were asking.
This is actually lazy loading?
No, it's not lazy loading. It's lazy. You should think about it as lazy rendering, not so much loading.
Okay, so what's the difference between lazy
Lazy loading is when you download the JavaScript code, and lazy rendering is when you render data like JSON into the displayed HTML. So you can combine the two, and if you look at what React is kind of doing with if you saw Dan Abramov's talk about what they're looking to do with an upcoming version of React, it's kind of like a mixture of these two technologies together of not rendering certain things until they're actually needed, but not downloading the code that does the rendering for these things, and then you can actually combine the two together. Almost done. Code profiling optimizations. Again, a topic worth a complete talk just on its own. Obviously, you can use, there are a lot of profiling tools that are built into Chrome DevTools. Using these tools, you can improve the performance of your code. You want to identify hot code, which means commonly executed code or commonly used functions, and focus on those. Don't just optimize willy-nilly. Premature optimization, root of all evil, and so forth. Use a profiling tool, find the code that's most commonly used, and then invest the time and effort in optimizing that code. Sometimes you actually find that you need to replace algorithms and data structures. If you're using bubble sort, then you probably want to use quicksort instead. That's obviously a silly suggestion. And prevent something called de-optimization as JavaScript code. Again, it's a topic that's probably worth a whole talk on its own. Just by doing profiling and optimizations, we've been able to improve code by 10 to 20%. That's less than what I would have hoped for. That's because there's such a huge variance in Wix sites that it's really difficult to identify code that's hot across the board for all Wix sites. If you're working on a particular site or a particular service, it's more likely that you'll be able to find code that's really hot. Also take into account that this 10 or 20% is on top of on a number that also includes network. So it's actually, if you just look at the runtime of the JavaScript, it's actually more substantial than that. So in conclusion, yes, I'm concluding. So you should demand performance, both as a customer or a user of somebody else's website or service, as a product manager, as a manager in the company. You should be demanding performance because that will go to your bottom line. You have, like we talked about before, you have to spec performance because if you don't make it part of the requirements of the specifications, it won't happen. You have to measure performance because if you don't measure, how do you know how good or bad you are? And how would you know if you're progressing or regressing? And obviously, you need to allocate resources because it won't just happen magically on its own. And remember, your customers have alternatives. If your performance, well, maybe not your customers in the army, there are no alternatives there, but otherwise, for everybody else, our customers have a choice. If we don't give them high performance, then somebody else will. Thank you very much. That concludes my talk.